Today on the dyno we've got a little Mazda MX-5 running on a Motorsport Electronics ME442 ECU. Now the vehicle's in today for a tuning session. It's currently running on a base map from Motorsport Electronics. Just going to talk you through the basic principles of where we start and how we do a job like this. Let's get into it. Now we've already gone through the calibration, checked, basic settings are correct, injectors, dwell times, all that lot. It all looks absolutely fine. We've checked everything's working, reading, intake air temp sensor, coolant temp sensor, etc. Everything's looking good. Now, one of the first things we always like to do, this is a base map, obviously, like I said, from ME. Everything should be pretty much bang on, but it never is. So one of the key things that we need to check is the trigger offset. Now, the trigger offset denotes, where TDC is, on the ECU versus the engine. So we need to double check that 0 degrees of timing is TDC, is 0 on the crank, to confirm that everything's right. So what we've done is we've hooked up our strobe, just got our basic timing light, and then down here in the engine, I'll just show you, we have got our crank mark. T is what we're looking for, that's our TDC mark. Now there is a yellow mark on the crank pulley, you can't see it, it's out of shot at the minute, but we're looking to see if that is in alignment with the ignition locked. So, ignition driver, fixed fire. We need to enable this. So fixed fire, yes. Fixed fire, advanced, 0. So that should be bang on the TDC mark. So let's start her up. And let's have a look. Now you may struggle to see that on camera, but it's out. So we need to adjust. We're about 6 degrees out. So we change this trigger offset to retard it by 6 degrees. So there we go. The engine note just changed as it retarded the timing. And now she's pretty much bang on. Maybe 1 degree more. And then we're perfect. Now this just highlights the importance of this. This whole entire tune would have been 6 degrees too advanced, which can be the difference between detonation and not. So it is crucial that you check your trigger offset, make sure that it is correct to your application, and move forward from there. So here we are, engine's all running, idling nicely, nice stable idle. We're just on our fueling table, our VE table. You can see that our lambda target, stoichiometric 14.7, and our current 14.3, our error is 0.35, so we're a tad richer than target, and that's where we want to be. At the minute, closed loop lambda control is deactivated for mapping, acceleration enrichment is deactivated for mapping purposes. We're just sort of monitoring our lambda, see how far beneath target we are, and we go from there. We always start with the fuel. We make sure we have a safe ignition timing table to ensure we've got no debt. I mean, we've got the Plex 2 knock monitor hooked up. We always hook this up so we can listen for detonation as well as see it. I mean, the ME has built-in knock control, but the knock sensors aren't wired up to this ECU for some reason. The customer obviously hasn't got around to that yet, which again isn't an issue. We always map it with the Plex anyway, regardless if it's a low horsepower or 1000 horsepower. It doesn't make a difference. We always use the knock monitor for safety. So always start with the fueling. We've got the dyno set to steady state at the moment, so we can hold the vehicle at a specific RPM, specific load, and we can go through it cell by cell and populate the fuel table accordingly and go forward from there. So this is the steady stating process that obviously you need a rolling road to do, ideally anyway. You can currently see, if I give it full throttle, this is the area we're working with. Target is 12.65 and we are currently too lean. So we'll just add some fuel. coming straight into where it needs to be now. A little bit richer than target, but again, that's where you want to be. Better to be a little bit richer than too lean. When we turn on the closed loop control, that will take care of the rest. So now that we've finished steady stating our fuel table, we haven't done any power runs yet, but we're going to come to that in a minute. We have now started optimizing our ignition timing table. Now on the dyno, you can see on the handheld device, torque in the top right corner. Now what we do is we steady state and we go through cell by cell and we hold the vehicle, same with the fueling, at a said load, said RPM, and then we optimize the timing table to achieve MBT, which is the minimum best timing. What that is it's the most amount of torque using the minimal amount of ignition timing, because obviously you want to achieve the most torque at the wheels while using the least amount of timing possible. Now more timing doesn't equate to more power. You know, you've gone past MBT, so more timing can mean less power. You can also get to a point where you haven't reached MBT but you get knock, which again is just down to the application, the fuel, etc. Every engine's different, every application's different, but the key is you want the most amount of torque with the minimal amount of timing, with obviously no detonation, nice and clean. That's the goal. So we've done this. We're going to go through steady stating as well. I'm not going to go through too much into it, but that's sort of how we do it. So I'll get into some runs after I finish optimizing the timing table, and we'll see what we've got. So now it's time for a power run. Just get the car up to speed and we'll see what the fuel is doing. Okay, full throttle. Okay, so what you can see, the orange line is our lambda target and the blue line is our current actual AFR. So you can see at this point here, which is 4,800 RPM roughly. A little bit lean here, it starts to lean out. What's a bit more fuel there? Comes back down to rich, or to target should I say, by about 5.9, and then leans a touch more. So we've got to put a bit more fuel in here. Apart from that, that's looking pretty damn good. So that last run we just did made 122.1 bhp at the flywheel, 114 foot-pounds of torque, nice smooth graph, clean run, no detonation. We're going to add a couple more degrees of timing, do another pull, see if there's anything to be gained. So we've just added some fuel in the area that we previously spoke of, and we've also just selected the whole area here, which is where we are at wide open throttle, and we've added 1.5 degrees. We don't want to go crazy, just 1.5 degrees. Again, I'm listening with the knock monitor, so let's do another run and see where we are. I'll monitor the fueling while we do this run. Okay, full throttle. That's a little bit better. And as you can see, much better. Still wants a tiny bit more, but a lot better. So that last run is hidden behind the blue run because it has traced it almost identically. 122.8, 114.2. So identical torque, BHP, a minute increase. Not worth the 1.5 degrees we put into it. So we're going to take that back out. And we're actually going to reverse and take some timing away now from our original pull and see if we've gone past MBT and see if we've overshot. If we make the same amount of power with less timing, as I said previously, that's the goal. If we lose power, then we leave it back where it was. Let's have a go. So in our timing table, where we previously added 1.5 degrees, we're now going to go in and we're going to remove 3 degrees. So obviously taking 1.5 degrees away from our original run. So we're going to do a pull and see where we are. I've also added some more fueling, so it should look a lot better. So I won't film this run, I'll do the run and then I'll show you the dyno graph after. So this is after pretty much our last run. Again, orange line is the target, blue line is the actual. No lambda closed loop correction at all. Slightly richens up at the top end there. A tiny hump right there. We'll put a touch more fuel in there, and then that's near as perfect. One thing also I forgot to mention earlier is the white line that we've got here, which you can just about see, 85%. That's the injector duty. So you always want to make sure your injectors aren't overworked. I mean, 85%, it's getting up there, but they're fine at that rate. They're pretty much sort of done. If this customer does decide to boost it in the future, obviously new injectors will be required. But yeah, that's all looking really good. I'll just go and check the dyno and see if we lost any power on the previous run. And if we did, we'll put the time back to how it was. Then it's time for a road test, and the vehicle is good to go. Enable the closed loop lambda control, and that's it. So here we go, guys. Is the dyno run with 1.5 degrees removed, and as you can see, it has made a little bit less power, 115 versus 122, and yeah, it drops off at the top end there. So we put that 1.5 degrees back in, and it's back to 122 horsepower. It's nice and clean, as in there's no detonation. Fueling's perfect, and it's good to go. Customer should be very happy. Thanks for watching, guys. If you like the video, please subscribe. So that's us all done with our little MX-5. Thanks very much for watching the video. If you liked it, hit subscribe. Thanks very much.